Hello dear learner, welcome back to the Zoom Chemistry Hub. Today with another interesting and fascinating video in which we will discuss the quantum number and their types. So what is quantum number? Quantum number are the numerical values that describe the positions, energy and behavior of electron in an atom. These quantum numbers are derived from the Schrödinger wave equation, and these numbers help us to determine the electronic configuration of an atom. So the quantum number tells us the position of electron, the energy of electron and the behavior of the electron. Next, how many types or what are the types of quantum number? So there are four types of quantum number. Principal quantum number represented by small n, mutual quantum number that is represented by small l, and it is also called the angular momentum quantum number. Third, magnetic quantum number, it is represented by small ml, and the last spin quantum number, it is represented by ms. Now we will discuss all these one by one. First, what is principal quantum number? The principal quantum number is represented by small n. And what represents principal quantum number? The principal quantum number represents the energy level or shell of an electron. Mean to say, the energy level or shell are the circular path around the nucleus on which the electrons are revolving continuously. So this energy level or shell are the circular path according to the Bohr atomic model. These are the circular path on which the electrons are revolving continuously, and these shell may be 1 2 3 4 and so on, and these shell are always in positive integers. Larger the n value, or the larger n means higher the energy and further from the nucleus. Mean to say, if the energy level large, it is further from the nucleus, that is first shell, that is the second shell, or the first energy level and the second energy level. So we can see that as we move from the nucleus, its distance increases from the nucleus of an atom. That is the example of hydrogen atom, which contain one electron in its outermost shell or in ground state. That is the nucleus of an hydrogen atom, and it has only one electron, so its electrons are present in first shell, or it is also called the ground state. Next is the azimuthal quantum number. Azimuthal quantum number represents the subshell and their shape of the orbital, and azimuthal quantum number depends on the shell number, that is depends on the n value, and value range from 0 to n minus 1. Each value of L corresponds to a shell. So subshell are the space in the shell. The subshell or the sub energy level or the orbital or the space in the shell where the probability of finding the electron is maximum, or where the electrons are present and move at that place. So these are called the sub energy level or subshell. And by the azimuthal content number we know the shape of subshell and their energy level. So this azimuthal quantum number represented by small l, and when the value of l is 0, the subshell is S and its shape is circular. And when L value is 1, this is it represent the p subshell, that is p orbital. P orbital when L is equal to 1, and p orbital have a dumbbell shape like this, and there are 3 p orbital, px, py and pz. And when L is equal to 2, then when L is equal to 2, then it is the d orbital, that is d orbital is a clover leaf shape like this. And when L is equal to 3, then it is related with f orbital, and f orbital are more complex in shape. For example, when n value is 3, how many values of L are possible? So we have 3 value of L possible, that is here is not 3 is not included here. When the n value is 3, then the possible value of L is 0, 1 and 2, and when the 0, then the s orbital, that is the value of n is equal to 3, so the value of L is 0, 1 and 2, so 3 are here, 3 are the n value and 0 means s orbital. Here 3s, then 3p, and when the value of L is equal to 1, it's mean p orbital, and if the value of L is equal to 2, then it is d orbital, that is 3d orbital. So we write the value of n with each other, and we write the value of 0, 1, 2 as 0 for s orbital, 1 for p orbital and 2 for d orbital. Next is the magnetic quantum number. Magnetic quantum number represented by small m and l. Magnetic quantum number represents the orientation of orbital in the space, and it depends on the L value, and the value range minus L to plus L including 0. For understanding, we take an example. For example, if L is equal to 1, then the orbital is p, and the possible value of ml when L is equal to 1, the possible value of ml is -1, 0, and plus 1, because the ml value start from minus L to plus L. Here when L is equal to 1, then its mean m value will be minus 1, 0 and plus 1. And minus 1 for px, 0 for py and plus 1 for pz. Next is the spin quantum number. It is represented by small m and s. And what represents spin quantum number? Spin quantum number represents the spin of an electron in an orbital. We know that electrons are present in the atomic orbital, and in the atomic orbital electrons spin, and this spin is represented by spin quantum number. And the possible value of spin quantum number is plus half and minus half. Plus half means the arrow is upright, and minus half means the arrow is down. And we know that from the Pauli exclusion principle, no two electrons in an atom can have the same set of quantum number. The Pauli exclusion principle says that if an electron have the value, then this electron have at least one different value. That is, here you can see that if an orbital contain two electrons, then these two electrons have opposite spin. That is, one is clockwise, then the other is anti-clockwise. This is called spin quantum number. Now we take a review. When we have principal quantum number is 3, then how much value of L? We know that we have already discussed that when the value of n is equal to 3, then there are 3 value of L. That is, when n is equal to 3, the L value is 0, 1 and 2. And 0 means s orbital, 1 means p orbital and 2 means d orbital. And in the p orbital you have already know that p orbital have ml value, that is minus 1, 0 and plus 1. If the value of L is 1, then we have 3 ml value. That is, if L is equal to 1, then ml value is equal to minus 1, 0 and plus 1. All today the learners, if you have any query related to this video or related to this topic, please write me in my comment box, which give me high motivations, energy. And if you like this video, please like, subscribe and share with your friends and fellows, so we can grow each other. Thanks for watching.